The purpose of Lab 5.1 is to use black and red tiles to provide a model for adding, subtracting, multiplying, and dividing integers. And so we're going to be using our black and red tiles in this lab, so I'll give you a few minutes to locate those. We're going to set up the concept that the black tile represents a positive value and a red tile represents a negative value. And I know that a negative and a positive are called zero pairs. So that would be our initial concept that we would need to know. That we have a negative, a positive, and they add together and they give you a net value of 0. So if you just pick up some tiles and drop them and you sort through them and you want to find the net value of what you've picked up, we need to find our 0 pairs. So if I add the black to the red, I have a 0. I have a black and a red, I have a 0. A black and red 0, a black and red 0, and what I now have left is 1, 2, 3, 4, 5 red, and red represents negative or values less than 0. So it's very simple to do computation using the manipulatives. So let's look at some examples. Let's say that I want to add 7 to negative 3. So I'm going to get 7 black tiles. Be sure that you're doing this with me. And I'm getting 3 red tiles. And I'm going to make as many 0 pairs as I can. So there's 1, there's 1, and there's 1. So what I have left is 4 black, and black is positive. Now we don't write the positive sign in front of a positive value. They have an equivalent value, therefore we just eliminate that. Alright? What if I have a negative 7 and I want to add that to a negative 3? So I need red. 7 red. And I need 3 red. So I do not need to get 0 pairs. I simply combine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 red, red represents a negative value. So I have negative 8 added to a positive 2. So I get 1, 2, 3, 4, 5, 6, 7, 8 reds, and I get 2 blacks. So now I am adding 0 pairs, and what I have left is 6 red, which has a value of negative 6. Now, in the examples that I've shown you, we have looked at what happens if the signs are different and what happens if the signs are the same. And again, what happens if the signs are different. And at no time have I given you a rule to use. So it's very important that you allow your students time to do these problems before you start throwing rules at them. Because if you allow them to do enough of these using the manipulatives, then they are going to develop the rules on their own. If the signs are the same, you add and use the common sign. If the signs are different, you subtract and use the sign of the number that has the greater absolute value. Now, I want to remind you what absolute value means. If I look at a number line, the absolute value of negative 3 is how far negative 3 is away from 0. So negative 3 is 3 units away from 0, because distance does not have direction. So I don't need a negative which says it's left of 0. I don't need positive which says it's right of 0. So the absolute value is 3. If I ask you what the absolute value of 3 is, it's going to be 3, because the distance away from 0 is the same for negative 3 as it is for positive 3. The absolute value of negative 1 is 1. The absolute value of 2 is 2. So the number that has the greater absolute value is the sign that you take when you are using the rules for addition. But by using our manipulatives, we did not have to use rules. Now with subtraction, let's say that we have 5 minus 8. Well, this 5 is positive, and so is the 8. So I'm going to have 5 black. And I'm going to have 8 black. Alright, so I want to take 8 away from 5, which is kind of a hard thing to do, right? So I can take this black away. I can take this black away. I can take this black away. and this one away, and this one away, but now I don't have anything to take away, and I have 3 more that I need to subtract. So I have to go back and think about my 0 pairs. So if I have 3 black and I have 3 red, then I have the ability to take away the 3 black that I need to take away. And what I have left now is -3. And I had no rules. I was just making my 0 pairs. Alright, let's look at another example. Say that I have -4 minus a +3. So I have 4 red and I have 3 black. Four red, 3 black. So I can't take black away from red. So I have to add in my 0 pairs. So to add a black, I have to add a red, so it's actually a value of 0. And a black and a red. A black and a red. So now I have 3 black that I can take away. Because I added the 0 pairs, I have the ability now to take away the 3 black. And I'm left with 1, 2, 3, 4, 5, 6, 7 red. So the answer is -7. Okay, let's look at 5. Subtract a -2. So I need 5 black and I need 2 red. Well, I can't take 2 red away. So I'm going to have to add 2 red to the first group. But if I add 2 red, I have to add 2 black so that I'm actually adding 0. So now I can take the red away and I'm left with 1, 2, 3, 4, 5, 6, 7 black. Okay, what if I have a -3 minus a -5? So I have to have 3 red and I have to have 5 red. So I have a -3 minus 5. Well, I can't take 5 away from 3. But I can add 2 red if I add 0 pairs. So now I have 5 red that I can take away from 5 red. And what I had left is 2 black. So the answer is 2. So I did not in any way give out any rules. you know the rule is change subtraction to addition by writing the opposite of the second number. So the rule would be -4 add a -3. Where the signs are the same, you add and use a common sign. This would be 5 plus a +2. The signs are the same, you add and use the common sign. This would be -3 plus a +5, and if the signs are different, you subtract, use the sign of the 5 because it has a greater absolute value. So the rules for subtraction and addition are the same after you change subtraction to addition. But when you begin teaching students about sign numbers, if you will use the red and the black squares to help them, then you will not have to introduce these rules. Maybe they will be able to develop the rules on their own. On multiplication, if you have 3 times -2, that means that you want to add -2 3 times. So that gives us a -6. If this had been 3, -3 times -2, we use this as we're going to take out two reds 3 times, and that would give you the black tiles. So if you have a negative out here, it means that you are taking out the -2 tiles and leaving them with the positive tiles. So the rules for multiplication and division, I think, sometimes are confusing. I really love using these manipulatives for addition and subtraction. I'm not as crazy about it for multiplication and division because the rules are so easy for multiplication and division. If the signs are the same, 2 signs the same, the answer is positive. If 2 signs are different, the answer is negative. And that's true for both multiplication and division. So I don't really see that the manipulatives are that important for the multiplication and division. But I do think you should use them for addition and subtraction. Okay, I'd like for you to illustrate to me, and you can use red markers and black markers um, so that you can scan it and send it to me to show these sums. Now, I want you to show as if you are teaching it to a student. So it's not, I don't want you just to come up with an answer. I want you to illustrate to me like you would to your students. Now that's nothing. This is just a -3 minus -7. So I want you to illustrate use black and red markers to show how to teach to your students. So this is your assignment from Lab 5.1.